So friends, let's understand the concept of electric flux. But to understand electric flux, you must have the knowledge of area vector. Area vector. Area is a scalar quantity. You know what is the area of the room, area of floor, area of ceiling. When a outward normal vector is taken along with the given area, then it is said to be area vector. To understand this, let us have a area, this area. This area is length into breadth, area is A. Let us have a normal vector here. This is the outward normal vector n cap. So when this n cap is considered and A is the magnitude, then here we are writing that area vector A is equals to A magnitude into n cap. This example can be understood by the simple word that we said that area of floor. When we said area of floor, then if this is the floor, then this is the outward normal vector. So area of floor means you are standing on the floor, that is the outward normal vector. So area is a scalar quantity and area vector is a vector quantity. Area vector is area of the body along which an outward normal vector. Since SI unit of area is meter square, so SI unit of area vector is also meter square. Very simple. Now understand what is electric flux. We have electric field. In any electric field, we are placing a area there. Then the total number of electric field line passing through that given area normally is said to be electric flux. So you can say electric flux is the measure of number of electric field line passing through a given area normally placed in a uniform electric field. I am writing this also. Electric flux, the measure of electric field lines passing normally through a given area is said to be electric flux. The symbol is phi and here E is written for electric flux, because in other chapters such as in magnetism there is magnetic flux also. There we write phi m. So distinguish between electric flux and magnetic flux, we use the symbol phi E and phi m. Now to understand electric flux, let us take here electric field lines. These are electric field lines. And let us place a area. This is the area placed here at inclined to electric field line. So this is the area vector A. Area vector. This is the angle theta between electric field and area vector. Resolve A into two components. This is A sin theta. This is A cos theta. So electric flux phi is equals to A cos theta into E, which can be written as E dot A. So electric flux phi is equals to E dot A. SI unit of flux, electric flux is, this is Newton per coulomb and this is meter square. So Newton meter square per coulomb is the SI unit of electric flux. You also know electric SI unit of electric field is volt per meter. So it is volt per meter and it is meter square. So what you have? Volt meter. So you can write volt meter. So SI unit of electric flux is Newton meter square per coulomb, or you can use volt meter. Now let us have another diagram to understand again this electric flux. In this diagram, this is the electric field E. and this is the area vector A. So area vector and electric field have the angle theta. So again resolve into two components. This is E sin theta, this is E cos theta. So these two are along same direction. So you have flux phi electric is equals to E cos theta into A. So you can write here again E dot A, electric flux in this situation also. When you take small area, then you write small electric flux d phi is equals to E dot ds, where S is area and ds is small area. Or you can write delta phi is equals to E dot delta S. This is small electric flux when area are taken is in small. Now if there are two type of surface, one is open surface, one is closed surface. If there is open surface, for open surface, you have electric flux phi is equals to integration E dot ds. This is for open surface. For closed surface, electric flux phi E, here E for electric, phi E is equals to closed integration E dot ds. This is open integration and this is closed integration. To understand closed integration, I am just taking a cylindrical body to explain this. Suppose you have a cylindrical body. This is a cylindrical body. Then this cylinder have three surfaces. This is surface 1, this is surface 2 and this is surface 3. So when you talk about closed integration E dot ds of this cylinder, then this can be break into three surfaces, that is surface 1 E dot ds, surface 2 E dot ds, surface 3 E dot ds. Thus these three surface integration are added to form the closed surface integration. So you have learned what is the theoretical part of electric flux. Let's understand numerical based on this. In this numerical number 1, electric field E equals to 2I plus 3J plus 4K. And you have, so I am drawing this diagram. This is a diagram here. So in this diagram, this is X, this is Y and this is Z. So our area is in YZ plane. Let we have a area in YZ plane. This is our area. And this area in YZ plane. So area is 20 unit in YZ plane. So area is 20 units in YZ plane. Then flux phi is equals to what? What is phi flux? So for this question, since this is in YZ plane, so direction is along x-axis. So area A vector is equals to 20 I cap unit plus 0 j cap unit plus 0 k cap unit. You know that flux phi is equals to E dot A. Put the values. The value of E is 2I plus 3J plus 4K. And the value of A is 20I plus 0J plus 0K. You know the dot product, that is A dot B in component form is AX BX plus AY BY plus AZ BZ. For more details, see my video lecture on dot product of vector. So here you have 2 into 20, this is AX, this is BX, plus 3 into 0, this is AY, this is BY, plus 4 into 0, this is AZ and this is BZ. So you have 40. What is the unit for electric flux? It is Newton meter square per coulomb. So 40 Newton meter square per coulomb. Remember, electric flux is a scalar quantity. Electric flux is a scalar quantity. Electric flux is scalar quantity. Now let us have another question for you. Suppose I am giving you a hemisphere. This is a hemisphere and this is the electric fields passing through it. Electric fields are coming from downside and moving to upside. Then what is the electric flux through curved surface? Electric flux through curved surface is equals to what? The question is. So for finding this, we will first find electric flux through this circular surface, that is base. So this is said to be base and this is said to be curved surface, symbolize CS. So electric flux phi through base is equals to electric field E is the electric field. So electric field and the area of the base. So area of the base in this direction, let the area of the base is A. So electric flux phi through base is E dot A. So what is E? E is only E, but E, and what is A? Let this radius be R. So A is equals to pi R square for circle. So you have EA cos 180 degree first, because this is in downward direction area vector and electric field upward direction. The electric field and area vector are anti-parallel, so angle is 180 degree. Cos 180 is minus 1, so you have EA minus 1, which is you can write minus E, and A is pi R square. So this is the electric flux through base. Now total electric flux phi is equals to phi curved surface plus phi base. As you are saying that number of electric field line entering is equals to number of electric field line leaving. So flux entering equals to flux leaving. This means that total flux through the surface is 0. So total flux is 0. So you have phi CS minus E, you have minus E pi R square. So you have phi through curved surface area equals to pi R square E, which is the electric flux through the curved surface area. Now let us have a second question based on electric flux. In this second question, I am taking a uniform electric field line. This is a uniform electric field line. In this uniform electric field line, let us place a circle here. It's not circle, cylinder here. Let us place a cylinder here of radius A. A is the radius. Then the question is, what is the electric flux through the cylinder? For solving this, we have surface 1 here, surface 2 here, and surface 3 here. So from surface 1, this is the direction of area vector. Let the small surface is here, so it is ds. In surface 2, you have direction of, this is ds, small surface 2. Here you have a small surface area, this is ds. What about electric field? In this electric field is in this direction. So electric field and surface area have 90 degree angle. What about here? ds and electric field E, both have same direction. So this means that angle theta is equal to 0 degree here. What about here? ds is in left direction and electric field is in right direction. E is this. So theta is equals to 180 here. So electric flux phi is equals to phi due to first surface, phi due to second surface, phi due to third surface. What will be phi due to first surface? Integration E dot ds plus integration E dot ds second surface plus integration E dot ds third surface. Now see, in first surface the angle is 180 degree. So write here E ds cos 180 degree. Give a sign of integration. In second surface angle is 90. So write here E ds cos 90 degree. And in third surface it is 0 degree. So write here E ds cos 0 degree third surface. You know that cos 0 degree equals to 1, cos 180 equals to minus 1, cos 90 is equals to 0. So this quantity become 0. So we have phi is equals to EDS with a minus sign plus EDS, this surface 1, this is surface 3, this is plus 1 sign. So you have integration ds, take E outside, surface 1, plus integration of third, take E outside, ds here. So first surface is pi r square. So you have minus sign is already here. So you have minus C, you have pi r square or pi a square. So write here pi a square plus E into pi a square. This is equal to 0. So electric flux through this cylinder is 0 when it is placed in a uniform electric field line. This can be easily said that number of electric field line entering the surface is equals to number of electric field line leaving the surface. So in that situation electric flux is 0. Thus you have learned what is electric flux, what is area vector, and how to solve conceptual problem and numerical problem on this. Do like, share and subscribe my channel Felix Gold Ravi Kumar. Thank you.